All right, here we go with trigonometry, also known as right triangle trigonometry. Now, before we get started on this notes, you do need access to an open Desmos tab because we're going to need these functions of sine, cosine, and tangent to be able to use these during our lesson. Okay, so be prepared with that Desmos tab when we need it. All right, we are going to start labeling this triangle first so we're clear on the parts. So first of all, let's go label what is considered the longest side, also known as the hypotenuse. This is the longest side opposite of the right angle, and that is called the hypotenuse. So go ahead and label that side opposite of the right angle. Here's our right angle. That's our hypotenuse. Then the leg that's nearest to you. Now, by the way, nearest to you what? Which angle are we talking about? We're going to consider this angle A our reference angle. Since we're using A as the reference angle, you're going to pretend like you're standing here at A. And what would this leg nearest you be called? The leg nearest you is going to be called the adjacent leg. So the leg nearest you is the adjacent leg. And finally, what would we call that leg that is across from you? So let's make this guy pink. The leg across from us is called the opposite leg. Okay, so now that we've got this whole thing labeled and we've got their names down, let's talk about these specific ratios of right triangles. Given specific names, this is right triangle trig. So the first one of sine, cosine, and tangent, the first one we're going to be looking at is sine. The sine of A. Now remember that A is our reference angle. So the sine of A is known as the opposite over the hypotenuse. It's a ratio of the two legs of the side of the triangle. It is the opposite over the hypotenuse. So if I'm standing here at reference angle A, my opposite over my hypotenuse would be that ratio. Okay, well, let's go take a peek at the next one, cosine. The cosine of A is going to be the adjacent over the hypotenuse. The adjacent leg's value. And finally, our last one is the tangent. The tangent of A is the opposite over the adjacent. Okay, so most people just remember one thing. I keep thinking I'm on highlighter, sorry. And this is like a little shortcut to remembering the name. And we call this Sohcahtoa. People write Sohcahtoa down at the top of their paper to help them remember which one of these trig functions has which ratio. So for example, the so stands for the sine function, being the sine of angle whatever is equal to the opposite over the hypotenuse. And the ka of the Sohcahtoa stands for the cosine of an angle is equal to the adjacent over the hypotenuse. And finally, the toa stands for the tangent of an angle is equal to the opposite over the adjacent. So by remembering this little trick, Sohcahtoa, we can remember quickly what the sine, what the cosine, and what the tangent stand for. Okay. Now I want you to notice one thing, that the sine and the cosine both have the hypotenuse in the denominator. And one other thing to note is that the tangent has no hypotenuse at all mentioned in its ratio. That will come in handy later. All right, so let's go look at some examples of actually applying this new ratio. So notice we have a reference angle here of 31 degrees, and we've been given an opposite leg and a longest side, the hypotenuse. So they gave me an opposite and they gave me a hypotenuse in this ratio. So I'm able to go ahead and set it up using the OH, which happens to be my sine of Sohcahtoa. It's the sine. So we set up the ratio as the sine of 31 degrees is equal to the opposite over the hypotenuse. So notice where the 31, the angle number goes in. Notice where the opposite went in, which happens to be our variable, and notice where the hypotenuse goes in. Now we're going to solve this equation for x. How do I get x by itself? I'm going to need to multiply both sides by 10 in order to get x by itself. And so what I'm actually plugging into the calculator right now is going to be 10 times the sine of 31. So here I go. 10 times the sine of 31. Times the sine of 31 degrees. And so our answer is 5.15. Now notice I'm going to have to round this. So 5.15 U for units, because this is a side length x. So why am I using these little approximation symbol? Because I rounded. Okay, so my answer for the side length of missing side length of x is 5.15 U for units. So again, how did I get that? I'm going to go back 1 second here and just show you how I set up the ratio and got that one more time. We look first at the problem to see what we have. We have an opposite and a hypotenuse. Which of the trig ratios uses an O and an H? We notice that the sine function uses the O and the H. So here I go setting it up. The sine of my reference angle, 31, is equal to the opposite over the hypotenuse. In order to solve for x, I need to get rid of this denominator by multiplying both sides by 10. And then so what I actually plug into the calculator on the next page is 10 times the sine of 31. And when we typed that in, we got 5.15 U for units. Okay, let's go try the next ones and see if you start to pick it up. All right, so for the next one, what do I have as in terms of my reference angle? Do you see that this time, the 40 being my reference angle, I have an adjacent leg, something that's very close or touching right alongside of my angle, and I have a longest side, the hypotenuse. So what uses an adjacent and a hypotenuse? That's my Ka function. So this time I'm going to use the ratio for the cosine of our reference angle is equal to the adjacent over the hypotenuse. So hang on 1 second. I'm going to go back and make sure you understood that. Why did I use the cosine this time? Because this time they gave me an adjacent with the hypotenuse. Notice that this was not given to us, this opposite over here. So what uses the adjacent and what uses the hypotenuse? That's my cosine ratio. Cosine is equal to the adjacent over the hypotenuse. So here I go setting it up. The cosine of my reference angle of 40 is equal to the value of the adjacent over the value of the hypotenuse. And now we go solving. In order to get x by itself, I'm going to multiply both sides by that denominator of 27. And what I'm actually going to type into the calculator right now is 27 times the cosine of 40. So here I go typing it in. 27 times the cosine of 40. And we get 20.68. How'd you do? Because I'm rounding, I need to use the approximation symbol because it's a rounded answer. Okay, let's look at what was given to us in the next one. This time my reference angle is up here. And notice that if I go across from that reference angle, I have an opposite and I have an adjacent right next to it. Notice that there was no hypotenuse given in this one. When there's no hypotenuse given, ding, 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 that's the tangent function. That's our TOA. The tangent function is the opposite over the adjacent. So here I go setting up my ratio this time in terms of tangent of my reference angle, 26 degrees, is equal to the opposite over the adjacent. How do I solve for x? I've got to get rid of that denominator by multiplying by 4 to both sides. And then I plug into the calculator 4 times the tangent of 26. Here I go plugging it in. 4 times the tangent of 26. And I get 1.95. U for units. Why am I using the approximation symbol? Because we rounded. Okay, what comes up on this last example here is a different way of having to solve. So again, I've got my reference angle right here. What they gave me was an adjacent and a hypotenuse, right? So which trig function uses the adjacent and the hypotenuse? Yep, you got it. It's a cosine function. So we're going to set up this time the trig ratio, the cosine of 37 degrees, the cosine of our reference angle, is equal to the adjacent over the hypotenuse. And we're like, oh, shoot. This time, I don't have a number on the bottom to just multiply out. This is going to take me a couple steps here in solving. I am going to bring the x up by multiplying. So I get x cosine of 37 degrees is equal to 500. So I just brought the x up. And now I'm going to be dividing both sides by the cosine. So what happens when we have the denominator as the x instead of a number as the x? So let me show you what I mean. Up here, there was a number below the x. There was a number in the denominator. There was a number in the denominator. We solved all of those by multiplying by that number in the denominator. This time, there's an x in the denominator. And so we have to do 2 steps. So instead of just multiplying to solve, we bring the x up and then we divide to solve. So this time when I go type this into the Desmos calculator, it's going to be 500 divided by the cosine of 37. Let's go see what happens. 500 divided by the cosine of 37. And so notice what I get. 626.07 is my rounded answer. 626.07. And this time, do you notice that they gave us kilometers right here as our units? Yay! We actually have some units. Oh, and back here, do you see this little tiny inches? So instead of putting U for units, I should have put inches. Let me go check the other ones. Oh my gosh, there was units everywhere and I missed them. Here there's M for meters. And there was nothing in the first one, so we'll just leave it as U for units. Okay, so what did we just learn? We just learned trig ratios. And this only works for right triangles. There has to be a 90 degree for this to work, right? And what do these trig ratios find? They help us find the length of a missing side. So wait a second. I know something else that helps me find the length of a missing side. What was that called again? Oh yeah, Pythagorean. With Pythagorean, I can do a squared plus b squared equals c squared. So why am I not using Pythagorean on these ones? Because they didn't give me 2 sides. They only gave me 1 side and an unknown. Here I have a side and an angle, so I'm going to use trig in order to solve for the missing side. If I had 2 sides, I'd use Pythagorean, but I don't, so I have to use trig. Okay? Hopefully this was a good review for you of these new trig functions. How'd you do?